Will we see an increase in Vibrio vinificus in the Chesapeake Bay? I am Sean Mansperger and I am presenting this Tableau story to you for my UMGC Data 620 assignment. This project involves data collected by buoys floating in the Chesapeake Bay. This is a photo of the buoy floating near Annapolis. First, let's discuss why I chose this particular topic and data sets. My family lives in a small coastal town on the western shore of the Chesapeake Bay. Each summer we see signs posted about the risk of Vibrio being present in the bay to alert the swimmers as well as the folks who fish from the pier. Bacteria like warm and relatively salty waters. The National Centers for Coastal Ocean Science, NCCOS, can correctly forecast 93% of the time where they can find Vibrio vinificus by using temperature and salinity measurements. They have many buoys spanning the bay which collect these measurements, as you can see in Figure 2. Figure 3 may have caught your eye, and it is an animated image created by NCCOS showing the progression of the daily probability of Vibrio vinificus in the bay's waters during the year 2020. I wanted to show you an example of how the data from these buoys are used. And you can see as it gets progressively warmer as the days progress into the summer, the percent probability increases. Here we have a scatter plot. We have blue for Annapolis, and Goose's Reef buoy is in green. The Goose's Reef is jogged a little bit over to the right, showing that it is more saline. The salinity is higher here, and that makes sense because it is south of Annapolis, and as such, it's a little bit closer to the Atlantic Ocean. Figure 5. These are temperature and salinity charts showing data from each buoy. Annapolis is blue again and Goose's Reef is green. Note how the linear trend lines are significantly different with each. These are time series graphs and you can see the seasonality of the temperature chart. Salinity almost appears to be seasonal, but it is not. Here in Figure 6, I've also shown turbidity, oxygen, and chlorophyll measurements over the same span of time. These are also included in the same data sets, but I'm going to move on here since we're not interested in these. Here in Figure 7, recall that the NCCOS uses temperature and salinity measurements in their predictive modeling calculations for Vibrio, so I'm forecasting temperature and salinity. I use the default forecast estimates, and I set it to use a forecast length of 2 years since I'm most interested in the summer of 2022. And here you can see average temperature forecasted near Annapolis and here for Goose's Reef. And the forecast precision here is plus or minus 3.913. Here I have combined the data sets and using an average, and I have annotated some of the points to show you. This is August, this is July, here's August, and we have an average temperature of 28.1. And for salinity, we have average salinity of 11.09. My confidence in this is very low with these forecasts because Tableau had a prediction of just okay for temperature and it was poor for salinity. And here are my references. Thank you very much for watching my presentation.